So, is the principle of a camera similar to how we recognize objects? Yes, the principle of a camera is similar to how we perceive objects. A camera detects light to form the shape of objects on film or an image sensor. When the image on the film or image sensor is either developed into a photograph or digitally stored, it becomes a picture. The specific principles of how a camera works are as follows. Gathering light through the lens, light is collected through the lens of the camera. The camera's lens plays a role in focusing light from objects onto a single point. Forming an image on film or image sensor, the light gathered through the lens forms an image on the film or image sensor. Film reacts to light, causing chemical changes, while the image sensor converts light intensity into electrical signals. Developing or digitally storing the image formed on the film is developed through chemical processes into a photograph, or the image formed on the image sensor is digitally stored. The principle of a camera is indeed similar to how we perceive objects. When we perceive objects, our eyes detect light, forming the shape of objects on the retina. The image on the retina is then transmitted to the brain, which interprets the image to recognize the object. However, there are some key differences between the principle of a camera and how we perceive objects. Adjusting light quantity, cameras can control the amount of light by adjusting the aperture and shutter speed. This allows for the capture of photographs with the desired level of brightness. Our eyes cannot control the quantity of incoming light. Capturing light's color, cameras can record the color of light because film or image sensors can differentiate between colors. While our eyes can perceive light's color, they also compensate for variations in color caused by changes in light intensity. 2D imaging, cameras produce two-dimensional images because film and image sensors are flat. In contrast, our eyes provide us with a three-dimensional perception of objects. In conclusion, the principles of a camera are indeed similar to how we perceive objects, but cameras have distinct characteristics, such as the ability to control light quantity, capture light's color, and produce two-dimensional images. Are there any digital cameras or cell phones that implement the function of an image sensor in 3D? Yes, there are digital cameras and smartphones that implement 3D image sensor functionality. These cameras can measure the distance to objects and create 3D images. The implementation of 3D image sensors can be broadly categorized into three main approaches. Stereo method. The stereo method uses two cameras to capture images of an object from two different viewpoints. By analyzing the differences between the images captured by these two cameras, the camera can calculate the distance to the object. Structured light method. The structured light method involves projecting a special pattern of light onto the object and then using the reflected light to measure distances. By creating a grid-like pattern on the object's surface and measuring the grid spacing, the camera can calculate the distance to the object. Time of flight method. The time of flight method measures the time it takes for light to travel to an object and back. This is often done using lasers or infrared light. By measuring the time it takes for the light to return, the camera can calculate the distance to the object. Many digital cameras and smartphones combine one or more of these methods to implement 3D image sensor functionality. Cameras with 3D image sensor capabilities are being used in various fields, including autonomous driving. Autonomous vehicles rely on accurate perception of their surroundings. 3D image sensors help measure distances to objects around the vehicle, enhancing safety and decision-making for autonomous driving. AR/VR, augmented reality/virtual reality. AR/VR technologies superimpose virtual images onto the real world or create immersive virtual environments. 3D image sensors are essential for these devices to accurately recognize the user's surroundings and provide more immersive experiences. Manufacturing. In manufacturing processes, 3D scanners are used to inspect product quality and detect defects. 3D image sensors can replace traditional 3D scanners, offering a more cost-effective and convenient way to acquire 3D data. As 3D image sensor technology continues to advance, the applications and utility of cameras with 3D image sensor functionality are expected to expand further in the future. Digital cameras and smartphones that implement 3D image sensor functionality are commonly referred to as 3D cameras. These 3D cameras can be categorized into three main types: stereo, structured light, and time of flight (TOF) methods. Stereo method. The stereo method utilizes two cameras to capture images of an object from different angles. By analyzing the differences between the images captured by these two cameras, the camera can calculate the depth or distance to the object. Structured light method. The structured light method involves projecting a special pattern of light onto the object and then measuring the time it takes for the pattern to reflect off the object and return. This method accurately measures the object's depth but can be relatively expensive and is sensitive to lighting conditions. Time of flight, TOF, method. The TOF method measures the time it takes for light, often emitted by lasers or LEDs, to travel to an object and bounce back to the camera. This approach offers fast and accurate depth measurements but can also be affected by lighting conditions. Each of these methods has its advantages and limitations. Stereo is relatively cost-effective but may struggle with accurate depth measurement. Structured light is accurate but more expensive and light-sensitive, while TOF is fast and accurate but also sensitive to light conditions. In recent developments, hybrid 3D cameras combine multiple methods to leverage the strengths of each while compensating for their weaknesses. 3D cameras find applications in various fields such as manufacturing, healthcare, engineering, and entertainment. In manufacturing, they are used for quality control and defect detection. In healthcare, they enhance the accuracy of surgeries, and in engineering, they aid in precision measurements. Additionally, they contribute to immersive experiences in the entertainment industry. While 3D cameras are still in their early stages, ongoing technological advancements are expected to broaden their utility in various fields. In South Korea, digital cameras and smartphones equipped with 3D camera functionality include digital cameras. Sony, Xperia Pro I, Xperia 1 IV. Samsung Electronics, Galaxy S22 Ultra, Galaxy S23 Ultra. LG Electronics, LG V60 ThinQ 5G. Smartphones. Sony, Xperia Pro I, Xperia 1 IV. Samsung Electronics, Galaxy S22 Ultra, Galaxy S23 Ultra. LG Electronics, LG V60 ThinQ 5G. These cameras offer various 3D capabilities, including 3D photo capture, 3D modeling, and 3D scanning.